Okay, we are solving a system of equations by graphing. And a system of equations is going to be two or more equations. For the purpose of this video, this is an Algebra 1 class, so we will only do two. But what you do is you graph both equations on the same graph grid, and where they cross, the point that they intersect in will be the solution to both equations. So you're looking for the one point that's a solution to each one of them. Realize that all the points on this line is the solution to that equation, and all the points on this line is the solution to the equation that matches that one. But there's only one point where they intersect, and it's a solution to both equations. All right, so we begin by graphing. We start at 3 on the y-axis, and we go down 2 to the right 1, down 2 to the right 1. Then we do the same thing here. We start at -3. This has a slope of 1, so we're going up 1 to the right 1, up 1 to the right 1. And they intersect at the point 2, -1. That is the point that will be true for both of these equations. All right, these two are not in slope-intercept form, so you must put them in slope-intercept form. So this is the first equation right here. You move 2x to the right, that gives us y equals -2x plus 5. We're going to do the same thing for this equation. We're going to come down here, subtract the x, put it over here. Now, be careful about your negative sign with the y. Be sure that you don't forget that it's there. Bring it down. You actually have -y equals -x plus 4. Divide through by -1 because we don't want to know what -y is. We want to know what y is, okay? That gives us this equation. All right, now we're going to plot both of them. We start at 5 and we go down 2 to the right 1, down 2 to the right 1 for that equation. For this equation, we start at -4 and we go up 1 to the right 1, up 1 to the right 1. And this is where they intersect. It is 3, -1. This one is here because it is a vertical line. We have a vertical line. And those always seem to give you trouble. So remember to use an XY table. Put -4 in for X all the way down, okay? Pick any other three numbers you want to for Y. Just be sure that they fit on your graph grid. Okay, so, and then plot those points, and that gives us these points. And then we're going to plot this line. It starts at 6. And it would go up 1 to the right 1 with a positive slope, but since we cannot go up and right, we're going to go down and left. So down 1 to the left 1, down 1 to the left 1. And then they cross at the point -4, 2. Now, an alternative method for this, since we know that x is -4, we knew that, we could have put -4, just substituted into this equation and found the y value where they crossed. That's another way to do it. Now, trying to decide whether a point is a solution to the system. In order for a point to be a solution to a system, when you substitute the point into each equation, it must solve each equation. If it doesn't solve both of them, then it is not a solution to the system. So both equations, it must be true for that point to be a solution. So we substitute in, we've got the point -4, -1, that's your x coordinate, y coordinate, and we substitute in, we get the same thing, it's true, okay? We come down, we do the same thing for this equation, substitute in, it is true. Therefore, yes, that point is a solution to the system. All right, is this one a solution? We do the same thing. Substitute in. As you see, this doesn't work for either equation now. So it's a no. But, however, if it had worked for this one but not this one, it would have still been a no. It's got to solve both equations. Okay, thank you.